Right, good morning. Welcome back to your chemistry class. And welcome to our third week of digital virtual online learning. Um, yeah, I hope you're well. I hope you had a nice weekend. Um, so we are going to start into something entirely new and different this week. Last week we did a whole lot with types of reactions, double replacements, products, predicting products, solubility, and polyatomic ions. So done a few weeks on those. Your quizzes are looking really nice, by the way. Those are coming in great. And as always, if you have questions on anything at all, um, bring those to class, send an email. We can do our own one-to-one Zoom time if you want. But yeah, figure out what questions you have and let's get those sorted out. And at this particular moment, we are going to launch into something entirely new. Off we go. And just preview, this is one of the units that I think of as being stairs. So I'll show you a new piece each day. And kind of for the next couple of weeks, kind of weeks 3, 4, 5, 6. This is kind of a big unit that we're getting into here. Each day is going to build just a little bit on the day before. Just keep all your notes with you, keep all your stuff with you, find your questions. All right. So everything that we're getting into here kind of has to do with like how much, how many. This is the kind of thing that if we had a whole bunch of labs, we would, you might be thinking about this already. Like, and in your videos, you watched when folks mixed some amount of stuff with some other amount of stuff, and it, if you watch that fourth video on Tuesday or whatever it was, I can relink that one. You might be wondering how much cloud was formed, like how much of that weird looking misty stuff inside of the beaker, and why that amount, and why not a different amount, and like, can we run out? How do we make more? Like, what, how do we know how much we're actually looking at? How do we measure that? And a related question, how much or how many, how do we even measure amount if, here's another thing that you probably remember from somewhere in your life maybe, but it is going to present a unique complication in this particular picture. You're like, yeah, I got that. Atoms are small. Atoms are real small. We measure atoms, the size of an atom. They're small, they're measured. The size is measured in angstroms. This cute little A symbol is like how you measure the size of an atom. You're like, that's cool, but what does that mean? An angstrom is 1 times 10 to the negative 10 meter. That's really small. So just for context, a centimeter is 1 times 10 to the negative 2. Centi is like 100. 10. So it's 1/100th of a meter is a centimeter. A millimeter, which is like the smallest thing that you can read on a meter stick, is 1 times 10 to the negative 3. So atoms are like really, 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 really small. Probably heard Bill Nye say that sometime previous year. And so they're super, super tiny. And so if we're getting at this question of how much or how many, it's not feasibly realistic to be counting the individuals, because that's just not a thing. We can't even really see individual atoms. Like recently we kind of could, but it's not a thing that we're going to do. If you're measuring like a bucket, you are not thinking about individual pieces in there. anything you can see has tons of atoms in it. So, to deal with that issue, we've invented a whole unit. We invented. Aren't you excited? You get a new unit. Invented a whole unit to describe a whole bunch of atoms. And again, this is handy because they're impossibly small. I shouldn't say impossibly. Eliminate that word from our science vocab. Nothing is impossible. Well, some things might be, but they're incredibly small. Like, we humans have a hard time even like imagining what that means because it's really, really, really small. Okay, and we want to work as macro level creatures to describe how much or how many anyways, even despite the size issue. So the unit that we use to describe how much or how many when we're looking at atoms, particles, molecules, or really anything that we want to count, is, I'll just give you this. The new unit is the mole. And to link this to something that you might already know, there's another unit that we use to count things. Another unit kind of like this is this, the dozen. So if we want to know how much or how many, but we don't want to be counting the individuals because that's too laborious, we could say a dozen, and you already know. You got this. A dozen is 12. That word means that number. Dozen eggs, 12 eggs. Dozen pencils, 12 pencils. Dozen shoes, 12 shoes. Dozen cars, 12 cars. Dozen cats, 12 cats. So the thing that you're counting doesn't matter at all because it's still, that word means that number. Same thing up here. That word means a number. The number it means is going to look a whole lot more like this kind of deal. And we're not, since we're counting now, like dozen as a counting number, it's not going to be the same as this meter stuff, but it's going to have some of your old friend from quarter one, the good old times two, the whatever stuff. Got some, you're gonna be doing some stuff with scientific notation coming real soon, and soon's now. So the mole, just like 12 is a dozen, the mole is, drumroll, 6.022. Thought you were gonna escape it, you're not, times 10 to the, this is really big, 23rd power. If you'd like, we can take a moment and say, okay, 6.022 times 10 to the 23rd power. We're going to pick up that decimal, pick it up from where it starts. We're going to move it 23 times. Off we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's where your decimal is going to wind up. So a mole, if you wanted, you could write the number of a mole as this number every single time. You're probably kind of putting together that is a really, really, really big number. And what that means, it is a really, 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 really big number. That kind of begins to kind of show you just how small an atom is. A single atom is like so small that this amount, the 6.022 times 10 to the 23rd atoms, that many atoms, is like, that's what we can actually see. So let's just say you were looking at the number of atoms in a cup of sugar. You can see the cup of sugar. That's a macro level thing. You can see it. To actually imagine how many atoms are in there, the number of atoms will look more like this, right? Like this whole huge amount. And it makes sense. You know that atoms are small. And we're just grappling with how small they are here. So something big enough to see in like the molar territory, you can see a mole of most, yeah, that's actually a decent way to say it. You can see a mole of most things, really. Even with your big human level macro eyes. Whereas there's no way you, with your eyes and no like fancy schmancy expensive microscope, could even begin to imagine seeing an atom. So really all a mole is a way to deal with how small atoms are. We kind of scale them up. We say atoms are so small, we can't even imagine how small. So we work with them in this quantity of a mole so that they're like 1 mole of atoms you can actually see. That's kind of the use of this crazy number. I'm going to link you a video on this also, and that'll be another way to kind of grapple with it. There's a decent chance that you have seen this word like other places in your world, because like, yup. Even last week somebody was reading ahead in the schedule and she was like, I know what a mole is, like, duh, like, I got this. It's like, yes, like, you're totally right. There's 2 definitions of mole that you already know, and now we are adding yet another. So this is a word that you know that we're just like giving this new definition to. And we'll get you some practice with it here in a moment. And like I'd say, you can figure out if you had a mole of shoes, like your own like shoes that you have on right now, like your favorite shoes, like how many times could you go to the moon? Like if you measured how big your shoe is, and then you had a whole mole of those shoes, like how far would it take you? Like which planet could you reach? Like this is a really big number right there. Or if you had a mole of, I don't know, drops of water. Oh, even drops of water. Oh. I'll show you if you have a mole of water molecules in this video. You'll see that. But what about drops of water? A mole of bathtubs of water? Like what planet would that be similar to? So you can take this number and start kind of messing with it and playing with it. If you want more review with scientific notation, let me know. We can totally do that. Actually, I'll make you a video that is review of scientific notation. And in our examples for today, we'll start using this number to math with it a little bit. I'll show you what some questions might look like and how you are going to use it. But that right there is your conversion factor. 1 mole is, I should write that down for you, 1 mole is that. Just kind of like 1 dozen is 12 things. 1 mole is 6.022 times 10 to the 23rd things. Alright, I'm going to make you a scientific notation video. I'll link the other one about the mole, and then we'll do some example problems.